let's go over one of the questions in the team round. So this one will be team number 10. And I really like this question. There's also a really fun theorem that you can learn from this. So here's the question. Sirius writes down the numbers 5 and 7 on the blackboard. He then writes the positive whole number n on the blackboard if it can be written as the sum of two distinct numbers already on the blackboard. Thus, the next three numbers Sirius writes will be 12, 17, and 19. How many positive whole numbers less than or equal to 100 does he write on the blackboard? So, seeing this question, it reminds me a little bit of what we call the Chicken McNugget Theorem. The Chicken McNugget Theorem is a very fun concept where if you have boxes that sell a certain number of chicken nuggets, I'm not sure, let's say, for example, let's say you can only buy chicken nuggets in boxes of 5 and 7. Then the question is, what is the greatest number of chicken nuggets that you are unable to buy using those numbers? So the theorem says that if you only have boxes of M and N chicken nuggets, then this number, M times N minus M minus N, is the greatest number of nuggets you cannot buy precisely. So you cannot achieve this exact number with these M and N nuggets. It's the greatest number of nuggets you cannot buy. So what this means for this problem, if we look at the way that these numbers are written, you can see that we can break up these numbers up here into their parts that are made up of 5s and 7s. And you'll notice that each of these numbers can be written as a sum of some amount of 5s and some amount of 7s. But there's a little bit of a catch to this. The catch is that each of these numbers has at least one 5 and at least one 7 in the sum. And that's because you're not allowed to add 5 and 5 together because the two numbers you add must be distinct. And similarly, you cannot add just 7s to each other. So what this means then is that you can think of 12 as being your starting number, and then you can keep adding some number of 5s to that, and then some number of 7s to that, and you will get all the numbers afterwards. So we start from 12, and we have to ask ourselves, at what point do we get the largest number that we cannot achieve with a sum of 5s and 7s? And in order to do that, we can invoke the Chicken McNugget Theorem. So we take 5 and 7 as our M and N. We got 35 minus 12, which is 23. So 23 additional nuggets to 12 is the largest amount of chicken nuggets you cannot buy. So 12 plus 23 is 35. So according to this theorem, 35 is the largest number that is not on the blackboard. It's the largest number that cannot be written as a sum of 5s and 7s. So this means any number greater than 35 can be written as a sum of 5s and 7s, and therefore all of these numbers are on the blackboard. And how many of these numbers there are? Well, 100 minus 36 plus 1. So that's going to be 64, 65, I believe. So far, within this range, there are 65 numbers. And then the question is, how many numbers are on the blackboard between 1 and 35? And with that, we're going to have to do a little bit of some careful counting to find that. So we start from 5 and 7, and we can use those to form 12. And we can add 5 to 12 to make 17, or we can add 7 to make 19. And you can keep building a sort of network like this just to be very careful that you don't miss any numbers this way. And this strategy is pretty nice because as you build this network from left to right, you're going to be sure you're not missing anything. So this forms 29 and also forms 31. 20, this one forms 31. That one also can make, I believe, 33. And what else is there? 27. Can 27? Yes, I forgot to include 27. That was pretty sloppy of me. Anyways, once we add all of those numbers, let's see what else there is. 27 can make 34. And we know that 35 cannot be on our list. So we just count up all the numbers that are here. And I believe that should be 14. So there are 14 numbers in this list. So 14 numbers are on this blackboard in this range. And also, all of these numbers are going to be on the blackboard. So we add up 65 and we add up 14. And so in total, the number of numbers on our blackboard is 79. That's our final answer.
This is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.